rational equations and how to solve them. When you're doing radical and rational equations, you do have to look for what are called extraneous solutions. These are solutions that aren't really solutions. Because of some of the operations you do, you have to consider the domain. Remember, we've talked about domain. So you should be in the beginning of week 3 of this course. So here's an example of an irrational, meaning ratio. If you think of the word rational, the first 5 letters spell ratio, which is a comparison, which is often written as a fraction. So this is a rational equation. Rational equations are not only equations with fractions, they're equations where the denominator has a variable. And so in the denominator we have a value for x. And we know that the denominator cannot equal 0. So in this case, x cannot be 0. So if we do our equation and x ends up being 0, we know that we have an extraneous solution, a solution that can't be the solution. Here we know that 5 times x cannot be 0, which is the same as saying that x can't be 0. Because the only way that you would get 0 by multiplying a number by 5 is if that number was 0. So that's how you find the extraneous solution, and that should be step number 1. Look for the extraneous solution. These are called Cornell notes when you write your steps on one side and you work out the problem or give examples on the other side. So the second step for this is to solve the equation. But when we're solving the equation and it has fractions, we first find a common denominator. So for finding a common denominator, remember that the whole number can be put over 1. So our denominators are 5x, x, and also 1. So we have only 1 as the other numbers besides 5. So 5 would be part of the common denominator. And then if we look, we also need an x. So 5x is our common denominator. We are rewriting the fractions with the common denominator. Okay, so we've made 5x our common denominator and changed the numerator accordingly. Now we can multiply through by our common denominator, which eliminates the denominator. Note that when I multiplied through by the common denominator and eliminated it, I also distributed this 5 into the x plus 2. So the last is just to solve for x. Last step. And you can do that on your own, and when you do, you will find that x equals -7 over 4. And if you're not sure why, you can pause the video and work it out and see how to get that answer. Okay, our first step would be to determine an extraneous solution. And then for your rational equations, we look at the denominator and see that the denominator cannot equal 0. So x plus 1 cannot equal 0. And in solving, we find that x cannot equal negative 1. Now we have to find a common denominator, and remember that this whole number is over 1, so it has a denominator, and our common denominator would be x plus 1. So we don't have to change the first fraction or the last fraction, but we do have to change this middle one to reflect x plus 1 as the denominator. In order to make x plus 1 for the denominator, we had to multiply it by x plus 1, and then we multiply the numerator by the same thing. Now we can solve this first by, now we can multiply through by the common denominator, which eliminates our common denominator. And then we simply have the numerator as an equation, which is not that difficult to solve. And in solving, you see that x equals 1. Our extraneous solution was negative 1, and since it was not that, this is a good solution. Alright, we will try another one. Alright, we're going to try another one. First, we determine the extraneous solution by looking at our denominators. We know that 2x cannot equal 0, x cannot equal 0, and 2x cannot equal 0, which means that x cannot equal 0. So if I get 0 as my solution, then I have to go back and say, well then, there can't be a solution. And that is because if x were 0, this would be 0, this would be 0, and this would be 0, and we cannot have 0 in the denominator. So next, we find a common denominator. Between these, 2x would be the common denominator. And when we make all of the denominators 2x, we have to take and change the second fraction by multiplying the top and the bottom by 2. And now we multiply through by 2x. Each fraction is multiplied by 2x, which cancels our denominator. So we're left with a very simple equation to solve. And then we solve this equation to find x. And our solution is x equals 2. Our extraneous solution was x cannot equal 0, and of course 2 is not 0, so we're good to go. This is our solution. We're going to try one more problem. So for this problem, first thing we're going to do is find our extraneous solution. So 5 can never equal 0, so we don't have to worry about that term. We set 5x plus 15 equal to 0 and find that 5 cannot equal negative 3. And when we look at the last term, we know that what's in parentheses cannot equal 0, because 0 times 5 would be 0. And so, again, x cannot be negative 3. So our extraneous solution would be that x cannot equal negative 3. Negative 3 would be the extraneous solution. So we have to make sure x is not negative 3. Next, in order to find a common denominator, we first have to have everything in its factored form. 5 is just one element, so it cannot be factored further. 5 times the quantity x plus 3 is factored, but here in this second term we can factor out a 5. And when we do, we have 5 times the quantity of x plus 3. Remember, this is opposite of the distributive property. If I take this part of it on the right and distribute this 5, I am back to 5x plus 15. So that shows me that my second denominator is actually the same as my first denominator. However, the first term is different. It needs to be multiplied by x plus 3 over x plus 3, so that all three denominators will be 5 times the quantity of x plus 3. X plus 3. So for the first term, I multiply the top and the bottom times x plus 3. Now I have a common denominator throughout, which I can now cancel out by multiplying through by the common denominator. And we ultimately get that x equals negative 3. Remember, however, negative 3 was our extraneous solution. And so x cannot equal negative 3. So our real solution is that there is no solution. So there is no solution to this problem. Now we're going to move on to radical equations. Radical is our name for the square root, cubed root, and so on and so forth symbol. This is a radical equation. So the first thing you have to do to solve this is opposite operation. The opposite of taking the square root of something is to square both sides. Sometimes, because we're squaring, and remember that idea that when you square something, it will always be positive, sometimes we end up with what is called an extraneous solution. So we always have to go back and test these to see if the solution is actually correct. So the first thing we're going to do is square both sides. When I square the left side, the square cancels the radical symbol. So then I have x minus 7 left. And 3 squared is 9. Last thing I do is add 7 to both sides and find that x equals 16. So I plug 16 back in to the problem. And so the question is, does the square root of 16 minus 7 equal 3? So I solve it and say the square root of 9 is 16 minus, the square root of 16 minus 7 is the square root of 9, which is in fact 3. And so this checks out. And so my answer is that x equals 16. Alright, let's try another one. This time the square root is only on the x. So I got to get rid of everything that is not here before I can square both sides. So I'm going to add 7 to both sides first. And I get the square root of x equals 10. And opposite operation, I'm going to square both sides. And x is going to equal 100. Okay, so let's see if this works. Make sure you always check it. So the question is, does the square root of 100 minus 7 equal 3? Square root of 100 is 10, and 10 minus 7 does equal 3, and so 100 is our solution for x. Alright, let's look at an alternative notation. When I say x to the 1/2 power, now this is not x times 1/2, it is x to the 1/2 power. So this bottom number 2 is my index. It tells me what root. In this case, I have the square root of x. This top number tells me what power x has, or that root has. In this case, 1, which doesn't make a difference. So I'm really just saying the square root of x equals 4. And so I square both sides and find that x equals 16. So to continue with that, x to the 2/3 power, the 2 is my index, which in this case means the cubed root of x, and the 2 on top is my power, cubed root of x squared. So for instance, if I had 8 to the 2/3 power, I would have the cubed root of 8 squared. And then to finish with that, that would be the cubed root of 8 times 8, which would mean for every 3 of a number I can cancel. And 8 is broken down to primes as 2 times 2 times 2. So we have both 8s broken down to 2 times 2 times 2, which would give us the 8 again. For every 3 2's, I cancel and bring 1 to the outside of the radical. And for every 3, again, I cancel and bring 1 to the outside. And so 8 to the 2/3 power is 4. 2 times 2, 4. Okay, now we're going to do another example. We have the square root of x minus 11 equals -5. So as before, the first step would be to square both sides in order to get rid of the radical. So we end up with x minus 11 on the left side and 25 on the right side. Now we add 11 to both sides and get that x equals 36. So now we want to check our solution. And when we do, we plug 36 in. 36 minus 11 is 25, and the square root of 25 does not equal -5. So for this one, we actually have no solution. The solution we got does not work, so it's no solution. We were going to be doing more rational and radical equations after we learn how to factor quadratic equations. Right now we can't do the harder problems because we don't know how to factor, but we will be doing them. So we'll revisit this topic. For now, just do your MyLabs Plus and then move on to lesson 7A. Thank you.